So before the break, we started looking at the non-right angle triangle version of the trigonometry. So can we still apply trigonometry in non-right angle triangles? Yes, we can, but we need to think about this kind of idea of breaking that triangle in half, okay? So one of the ones that I came up with was the sine rule, which is literally just looking at the ratio of sides, okay? And you can do that using the sine rule, okay? But sometimes the sine rule won't work. I want to discuss when it works and when it doesn't work later on. For the moment, I just want to sort of show you another rule that we can apply just by looking at it a slightly different way. We've looked at the sine kind of ratios. Let's see if we can do the same using the cosine ratios. We can, but we just need to be a little bit more clever. So I'll do the same thing as I did before. I'm literally just going to cut this triangle in half to form two separate triangles. But now what I'm going to do is try and make use of this side which I've kind of cut. Of course, I say cut in half, it could be in half, but more likely I've just dropped a perpendicular down, so I've just got two different triangles. These lengths may not always be the same. So I'm going to try and make use of this side that I've cut, okay? So look, if I call, what shall I do? Yeah, I'm going to call this side here, so in other words from where the angle C is, to where I've made my cut, I'm just going to call it x. Okay, I'm just going to call it x. Now have a look. The whole length from here to here is b. So what is that little length left over in there? So the whole length from there to there is b. I said that. That length is x, so therefore the leftover bit has just got to be b minus x. If I add those two things together, I should end up with b again. Make sense? Okay. Now I'm going to consider the two triangles separately. So this is my left one now. Have a little bit more information about what's going on, okay? That length from here to here, the one which I've used to cut that triangle up, okay? I'm still going to call h, okay? I'm still going to call h, okay? So that's right angled now. This angle here is a. This side from here to here, I now know that is b minus x, okay? From there to there. And this is c. So far, so good? Yeah? Okay, let's have a look at the right triangle then. Let's see what I've got. So I know that's a right angle. This is still going to be h, it's literally the same length. That's a. This angle here is c, okay? Remember, this is b, like these two things put together is b, but because I've chopped it up, and I don't know what ratio I've chopped it up in, there's not much I can do there. So I'm just going to leave it off. And this side across here is going to be x. Cool, okay. So, what can I do with this? Any suggestions? All right, well, look. Let's say with this triangle here, okay, because they're both right-angled triangles, would you be happy that I could use Pythagoras? Just simply to link the sides together. Happy with that? Okay. So let's have a go. With the left triangle, I'm just going to use Pythagoras, okay? I'm just going to use Pythagoras. So what's it going to be?
A squared plus b minus x squared equals c squared.
Good. That side squared, which is h, plus that side squared, which is b minus x, has got to be equal to the square of the hypotenuse. That's just Pythagoras. Just Pythagoras, okay? If I use Pythagoras on this triangle, what do I get?
A squared plus x squared equals a squared.
Good. That side squared plus that side squared has got to equal that side squared. All good? Yeah, all good? All right, fine. Let's have a look at this. Well, I could expand the b minus x all squared out, couldn't I? Could expand that out. So in other words, I could say that h squared, if I expand this out, what do I get?
B squared minus 2bx plus x.
X squared has got to be equal to c squared. Perfect, okay? Now have a look over here. Would you be happy that x squared has got to be equal to a squared minus h squared? Happy with that?
Yes.
Yeah, I've literally just rearranged that formula, okay? So let's have a look at this then. Have they done the same as me? Yeah, okay, that's fine. So have a look at this then. What do I need? Well, would you be happy that x is the thing which I've introduced? I've introduced an x. I'm trying to get rid of that x if at all possible. Okay? Now I could get rid of that x squared because I know that x squared is a squared minus h squared. Happy with that? Okay. But I still need another formula. I still need another formula to find out what x is. I don't just want to square root that because it gets a bit messy. So I just want to find an x from this triangle here. Well, I don't, if I can get away with it, I don't really want to use h either. Okay, because h is just the length which I've kind of made to cut the triangles in half. So I've got three sides and I've got an angle. I don't really want to use that side because I don't know its length, but I do know A and I can find out what x is by using B. Okay, so how would I link together these two sides with this angle? Cosine. So what would I say? Cosine of C must be equal to, good, must be equal to x over A. Which means if I rearrange this, because remember I want to substitute x back in here, if I rearrange it, would you be happy that x has got to be equal to A cosine C? Perfect. Okay, A cosine C. So now I have two formulas which I can stick in here. Remember my goal, okay? I don't know what x is. I just know that when I cut my side in half, okay, I don't know what h is either, but when I cut my two triangles in, or my triangle in half into two triangles, that length I'm just calling x. I don't know how long it is, but whatever's left over, that's going to be b minus x. So what I'm trying to do is come up with a formula that gets rid of any x's and gets rid of any h's. Is that okay? Yeah? So now I've got something for x squared, I'm just going to stick him in here. And now I've got something for x, I'm just going to stick him in here. So let's see what I get, right? So have a look. I have h squared plus b squared minus 2b. Now I've got an x, okay? So I can make a substitution for a cos c. Happy with that? So I'm going to actually rewrite it as ab cos c. But it doesn't matter, okay? Just 2b times by a cos c. I've just swapped around the a and the b. Plus x squared. Well, I know that x squared is just a squared minus h squared. Okay, so a squared minus h squared, and that's got to be equal to c squared. Are you happy with that? All I've literally done here is I've looked at that right triangle, I've found two formulas which have got x, I've got a formula for x, and I've got a formula for x squared, it's just Pythagoras and trigonometry, okay? And I've substituted it into this, which remember was just Pythagoras. Is that okay? So in other words, I've got rid of this x, and I've got rid of this x squared just by substituting the formulas in. That is all I've done. Is that okay with everyone? Right? Now I can do a bit of tidying up. Because would you be happy? The h's, remember I don't know what h is either, but I've got h squared there, and I'm taking away a h squared over here. This is looking good, right? This is looking good. So let's have a look what I've got. I've got a squared. Okay, so I'm going to write this in some kind of order. I've got an a squared and a plus b squared. So would you be happy I could write a squared plus b squared? Okay. Then I'm taking away this thing, so I'm taking away 2ab cos c. What's all that got to be equal to? C squared. Okay, it's got to be equal to c squared. So this here is another useful formula. Another useful formula. It's basically the equivalent of Pythagoras, so it links together these three sides, but it's done with a non-right angle triangle. Okay, so this is another formula which you need. Now, actually, you won't tend to see it written like this. You won't tend to see it written like this. I've just sort of kind of arbitrarily chosen the letters, and it's just the way the formula came out of it. Okay, but effectively, this letter here and here, the c squared and the cosine of whatever the angle is, the cosine of c, they always have to match up, and then everything else will change. So another version of this formula which you might see, if I say that a is the thing which I want to find instead of c, I could say a squared has got to be equal to, well now the a's, yeah, go on.
B squared plus c squared.
Yeah.
Minus b multiplied c.
Two lots of that, yeah.
And cos a.
Perfect. So that is literally the same formula as this, it's just looking at it from a different perspective. I've just labelled up my side slightly differently. That's all it is, okay? And this tends to be the formula which you find sort of written down and sort of in the formula book, okay? Now, you notice at the moment, this is in terms of the angle. So if I want to find an angle, this is the formula which I'm, sorry, not an angle, side. Because it's lowercase on this side, so it's in terms of a side. So if I want to find a side, okay, then that is the formula which I'm going to use, okay? But a quick rearrangement will be able to find me a formula for the angle, okay? So in other words, if I want to find cos A, really simply, I just rearrange all of this lot. So if I take away b squared and c squared from both sides, I end up with that. I've literally just taken away b squared, taken away c squared. Okay, so I've got a squared minus b squared minus the c squared, and I've just got that left on the right-hand side.
Is that negative 2bc?
Yep, negative 2bc cos A. Because I've still got the negative 2bc cos A from there.
Okay.
Yeah? Now, at this stage, I guess I could divide through by my negative if I wanted to. Okay, so if I divide through by negative, this becomes 2bc cos A. And on this side, all the signs get switched because I'm dividing everything by a negative number. So this becomes negative a squared, this becomes a positive b squared, and this becomes a positive c squared.
Why are we doing that?
Because it just makes the formula look a bit nicer. You don't have to. Yeah. And then all I want is cos A, so I'm going to divide everything by 2bc. So if I divide everything by 2bc, I've got b squared plus c squared minus a squared. Happy I've just written as a negative a squared over there. Divide through by 2bc, that thing there should be equal to cos A. Okay, so in other words, another formula, if I want to find an angle, is cos A is equal to b squared plus c squared minus a squared, all divided by 2bc. Okay, that's if you want to find an angle. Okay, so we now have two formulas. We've got this one, and we've got this one. Let's see it in action. So let's have a go with something like this. Let's suppose that there is 60 degrees. Let's suppose that there is 5. Suppose that there is 6. And we want to find that side there. Okay. Now, I would advise you to let A be the thing which you want to find. Okay, so that's what I want to find. So I'm just going to label that A. If that's a little a, what's that angle going to be?
Sorry?
If that's little a, what's that angle going to be?
A.
Capital A, perfect. And it doesn't matter whether I call that B or C, it doesn't matter which way round I put it. Okay? So now what I do is I think, well, am I finding an angle or am I finding a side? A side. So I'm going to opt for that top formula because it's in terms of a side. Remember, these two formulas are the same, they're just rearranged. Okay? So let's go for the top one. So I'm basically saying that a squared is equal to b squared plus c squared minus 2bc cos A. And then I just fill in what I have. So, what is A in this triangle here? It's x, yeah? So x squared. Plus, well, what's b? 6, it's going to be 6 squared. Plus c squared, which is 5 squared. Minus 2 times b times c, so 2 times 6 times 5. Times by the cosine of A, which is the cosine of 60. Okay? Now, if you stick this in a calculator, you get 36 plus 25 minus 6 times 5, which is 30, because that's going to be equal to half. Okay? So let's have a look. You get 6 plus 5, so x squared has got to be equal to 31, which means that x is going to be equal to root of 31.
What about negative 2?
So what I've done here, so if you stick this thing in your calculator and take the square root, you should end up with square root of 31. Okay? But if you have a look, what's the cos of 60 again? Somebody remind me.
1 over 2.
Okay. So cos of 60 is equal to a half. So I did that in my head. I did a half times 2 is 1. So it's just basically 6 times 5, which is 30. Yeah? Right. But it doesn't matter. You can sit there in a calculator and you can work that out. Now you notice, look where we've come from. We've come from some side squared equals 31. Why am I not putting plus or minus here? I've always told you if it's something squared equals 31, you take the square root, it should be plus or minus 31. Absolutely right. Remember that x here corresponds to a length. It doesn't make sense to have a negative length in this example here. Okay, so it's fine just to take the positive root. Yeah. Are there any questions about that?